Now we're trying to find this vector, the component of f in the direction of delta s, and we've determined that this component will have a magnitude equal to the magnitude of f delta s over the magnitude of delta s, and that this will be either positive if f has a component in this direction or negative if the component is in this direction. So that the desired component is just f delta s over magnitude of delta s multiplied by a unit vector, u being a unit vector in the direction of delta s. Now, what is a unit vector in the direction of delta s? Well, u is just going to be delta s divided by the magnitude of delta s. To find a unit vector in the direction of a given vector, we just divide that given vector by its magnitude. So, the component of f in the direction of delta s is f dot delta s over the magnitude of delta s, this telling you how big that component is and also whether it's in the direction of delta s or opposite, and then we just multiply that by the unit vector, which is delta s over the magnitude of delta s, and we call this the vector projection. This is the let me write that in ink here. This is the vector projection of f onto delta s. And we write that as PROJ for projection sub delta s of f. Projection onto delta s of f. That's what this vector tells us. Now this vector can be written as f delta s over the magnitude of delta s quantity squared multiplied by delta s. I prefer this notation because this expression can be traced back to the definition of the dot product and to the picture of this triangle, whereas this notation kind of obscures that. And we see the unit vector here, we see the projection here, but either expression will get you there.